Okay, so today in class, we're going to learn how to uh, write equations that we've been looking at, precipitate equations that we've been looking at. We're going to write them a little bit more accurately. So we're going to use something here that we're going to call a net ionic equation. Right, so a net ionic equation shows only those particles involved in the reaction and is balanced with respect to both mass and charge. Okay, so we're going to take a look at this reaction that we saw as a demo in class. Um, and we've used a couple of times here, a lead 2 nitrate reacting with potassium iodide. Now we both know that both of those are aqueous solutions here, and we know that it creates one precipitate and also one aqueous solution. So if we take a look here at what we're going to do, um, it says step one, write the molecular equation. This is what you've already written. We've written before. You've written in your lab here, right? It shows the overall reaction, um, but not necessarily the actual forms of the reactants and products in the solution. So let's write this first, and then we'll talk a little bit about what this means. Here we go, right? So lead 2 nitrate reacting with potassium iodide, right? And since this is a double replacement, right? We know that we have potassium nitrate, and potassium nitrate is definitely aqueous because all things with potassium and all things with nitrates are aqueous. So that's a solution. And then our precipitate in this case is our lead 2 iodide. Right? Okay, so if you remember the simulation that we used here, right? I'm going to put a couple of potassium iodides in there. Actually turn this off here real quick. Right. So what we notice in here, right, to begin with, is I actually don't have potassium iodide or lead 2 nitrate. What we really have, I know the leads and the nitrates are together on the screen here, but we know that that's just because of the simulation. We've talked about that. Um, what we really have is just a container full of ions, right? We know that in both of these instances, the attractive forces between the water and the ions are greater than the ions themselves in potassium iodide or lead 2 nitrate. So we just have two aqueous solutions in here. Now, once we let this run and we let these ions interact with one another, right? Now we formed this lead to iodide. That's a solid. We know the intermolecular forces or the attractive forces, sorry, between the lead and the iodine now is stronger than lead in water or iodine in water. So they have formed now a new compound and have dropped out of solution in the form of what we call a precipitate. But as we look here, our potassium nitrate is not really a solution here either, right? These ions are just in the solution. So what we want to look at here is a more accurate way of really describing this kind of reaction that we have here. Okay. So right, it says here, write the complete ionic equation. It says represent all reactants and products as ions in water. Right, because before the reaction takes place, like I said, we really had lead ions, nitrate ions, potassium ions, iodide ions, right? So for a complete ionic equation here, right? A complete ionic equation. We're going to represent this in a little bit more true fashion. Okay, this is going to be a lot of writing, but I have faith in you. You all can handle it. What we're going to do is we're going to write everything in ion form. Now, really important, we're going to write the charge because it's an ion. We are going to write AQ because it's in solution for each and every one of these ions. right? So when we go back to our animation here, if we were to reset this, right, and let some of these disperse a little bit, let some of these disperse a little bit, right? So this is really what we have, right? What we're looking at here in this equation is really, right, the lead 2 iodide or lead 2 um, is aqueous, the nitrate is aqueous, the potassium is aqueous, the iodide is aqueous. That's really what we have here, right? So really the reaction, the only thing that's really a reaction is when our lead interacts with our iodine. That's really the only thing that's an actual reaction in here, right? Where things are changing form. So over here in our reaction, we're going to, any place that we see AQ, we will continue to write AQ. But then after the reaction, our lead 2 iodide is actually a solid, right? So this is actually a reaction here. Okay, so this is the way we're going to write this, right? Lead 2 is aqueous at the beginning, nitrate is aqueous at the beginning, potassium is aqueous at the beginning, iodide is aqueous at the beginning. But then afterwards, right, we have potassium uh, ions and nitrate ions that are aqueous, but the lead 2 iodide, sorry, is here or is a solid. So it says, hey, let's get rid of these spectator ions, right? These things that really don't play a role in the equation, right? Potassium and nitrate ions both really don't do anything. They started in solution, they end in solution. The attractive forces between the water and those are stronger. There really is no such thing as potassium iodide, or I'm sorry, potassium nitrate in this solution or in this equation, right? We see them both as reactants and products. They're just kind of like the water molecules. They're just spectator ions. They don't really do anything. Um, so it says now we're going to write what we call the net ionic equation, right? Includes only those components that undergo a change. Spectator ions are not included. So really what we're interested in is just writing the equation that creates the only thing that actually changed, and that is our lead 2 iodide. So we're going to write, there we go, right? We have lead 2 reacting with iodine, and that produces lead 2 iodide. This is a net ionic equation. Now, our last step says use the coefficients to balance both mass and charge. In other words, overall charge should equal 0 and atoms should be balanced. So we're really going to just put a coefficient here, right? So for every one lead 2 and 2 iodides, we make one lead 2 iodide, right? Okay, so on the back of this, is another one for you to try. Why don't we take a second here, and you can try this one. Okay, so here's what you should have. Right, we wrote our molecular equation here, just like we've been writing it. We should find that iron hydroxide is our precipitant here. All right, our net ionic equation. Everything that is aqueous, we break apart into their ions. Right? So potassium ion plus hydroxide ion plus iron 3 ion plus nitrate ion then produces our potassium ion, our nitrate ion, and our iron 3 hydroxide precipitant. Right? And then here is our final net ionic equation. All right, so make sure you take a look at the lab. You're going to be writing a lot of these here for the lab that we did. So let me know if you have any questions.